Sorry.
Alright, so today we're going to be talking about shapes. We talked a lot about shapes in class. Lindsey and Dana spoke about shapes as far as coordinate geometry. So we're going to try and mix it up, talk a little bit about something we haven't talked much about.
Okay, so some of our objectives for today. One is to be able to differentiate a polygon from a non-polygon.
Alright, from there we're going to move on to talking about circles and specifically how to calculate the circumference of a circle. And our activity is aimed at having you all build your own understanding of what circumference is, what diameter is, and essentially what a circle is. So, we're also going to talk, I guess, a little bit about the procedural method and using the formula when it's like okay to do that, and when you shouldn't do that.
And we also want to talk about some of the misconceptions that students have about circles, so then when you go into the classroom, you can address the various misconceptions.
Alright, so polygons versus non-polygons. Polygons are two-dimensional shapes. They're made of straight lines, and the shape is closed, meaning all lines are connected. We have some examples of polygons right up here. In our research, we found that polygon actually comes from the Greek language, poly meaning many, gon meaning angles, so many angles.
And now, knowing this information, what is a non-polygon?
Can anybody answer that? What a non-polygon would be? This is the definition of a polygon.
Yes.
Shapes that are open.
Shapes that are open, correct. What
Or-
else?
Shapes that curved lines.
Okay, curved lines. Anything else? Yep.
It's three-dimensional.
Right, three-dimensional wouldn't be a polygon. And anything else? What about the lines are intersecting? Is that a polygon? Okay. So here we have some polygons and non-polygons.
This slide just really summarizes the last slide. All the polygons on the left here are all have straight lines. They're all connected. They're all closed, so all two-dimensional. And then on the right, you have the open ones, just like you guys said, curved lines.
Okay, so today, since we focused a lot in class about polygons, we talked about them, we're going to focus on one particular non-polygon, which is the circle.
Very cool.
Whoops. And a circle is a plane figure bounded by a single curved line called its circumference, every part of which is equally distant from a point within it called the center.
Alright, so some of the common misconceptions that we found when we were putting together our lessons and putting together our presentation in our research was that students often confuse the radius and diameter. Like this little child right here, he looks very confused. That's because these are just words to them. They don't really have any meaning. So one way to address that kind of misconception would be to simply just have your students draw and label a circle. So right here we have the diameter, the radius, circumference. Give those words some meaning.
And also, we have some great children's literature, which we'll go over more in detail later. But this one book here, it's Circumference in the First Round Table, and this just talks about, it's a story about, it takes place with the knights and kings, and we have Lady Di of Ameter, and their little son is Radius. So in the back of the book, I'm not going to read the book, but just to show you, her height is measured as the diameter. And then her son's height is the radius. So even if kids, like if you read this book to the children and they're able to think, okay, well the diameter, if you think Lady Di of Ameter, which is the character in the story, she's the tall one, and her son is half her size, they can kind of remember diameter versus radius because they may mix those up. Okay, so this is a great book to introduce the parts of the circle.
Alright, so another misconception students often have is confusing things like spheres and circles. And that's typically younger students And the reason for that is because teachers tend to dumb the language down. So one way you can address that is just by simply using the proper names for three-dimensional shapes. So the teacher in a kindergarten class, instead of calling the circle, or the ball a circle, call it a sphere.
So the kids, even as early as pre-K and kindergarten, they'll be able to understand, okay, this ball is a sphere, not a circle. A circle is two-dimensional. Like when I was observing in a pre-K classroom, when they would sort the objects, they'd sort, a ball and a fruit into a circle, but the kids will know that they'll know it's a sphere if you just introduce that language to them. Okay, and our third misconception is that people might think that a circle is an infinite-sided polygon. That if you, this is a little abstract, but if you make the sides of the sides of a shape smaller and smaller, like we have a 20-sided polygon, a 100-sided polygon, the sides will get smaller and smaller. So they say that a circle is an infinite-sided polygon. But if you talk about the definition of a side, it's a straight line edge that has some kind of a length, and if it's just a bunch of dots, there's no length. Therefore, it can't be an infinite-sided polygon. Okay. So today we're going to do a little bit of an activity with regards to measuring circumference and the diameter. So I'm going to just break you up into groups, just 4, 4, and 4, whoever you're sitting next to. And what we're going to do is each group is going to have a different size circle, and you're going to measure the circumference of the circle first, as well as the diameter. So we're going to give each group a piece of string. If you need longer, then we can give you longer. Yeah. You girls. Oh, sorry. Thank you. Louise. Yeah. Hold on. 2, 3, 4. Okay. Oh no, actually, I could just work in group of 3s. Sorry, working group of 3s. Don't we have 4 circles, John?
Yeah, we have 4 circles.
Oh, yeah. So 3, I'm sorry. 1, 2, 3, you those work together. 1, 2, 3, work together. 1, 2, 3, work together. So does each group have a different size circle? Okay. So how do you think you can use the yarn to figure out the circumference? If the circumference is the whole entire circle. How do you think you can use the piece of yarn? Yes.
You line the circle with the yarn and then measure how much yarn it takes to line the circle.
Excellent. Does everyone understand that?
Yes.
No? Or yes? Okay. You can cut the string, you can do whatever you need to, and then we'll give you some rulers so you can measure the circumference, and then right where it's the circumference you can label it. Yeah, and then you could tape it as well. Now you want to make sure that you work as carefully as possible, leaving no room for error. Okay, you really want it to be an exact measurement. And also don't stretch the string. How are we doing over here? Do the best that you can.
I rule.
I'm sorry, use inches. Use inches. Everybody use inches.